Hello everyone, welcome back to our Modern AI with Unsloth.ai series. In the previous notebook, we did the full fine tuning of a small model. In this notebook, we are taking a more parameter efficient approach using something called as LoRA, which stands for low rank adaptation. What exactly is LoRA? So instead of updating all of the million or billion of parameters, which is not efficient for a pre-trained model, what uh, LoRA suggests is that inject a small set of trainable low rank matrices into specific layers. At the same time, freezing the base model weights. So in this way, it trains the small set of low rank matrices into specific layers, which is much more efficient. This means we can fine tune models much faster using low GPU memory and still achieve strong task specific performance. For example, uh, only 0.5 to 5% of parameter may be trainable in a typical LoRA setup, while other are still not in use. So it is much more efficient technique. Now, in this notebook, we'll reuse our model, the same that we used, small LM2 with 135 million parameter, and the data set will also be the same, but the change is in the tuning strategy. We'll freeze the model weights and train the LoRA adapters, and we'll walk through each steps how it exactly works. Yeah, so this is the initial step, uh, installing and importing the required library for parameter efficient tuning, importing the necessary Unsloth.ai utilities. Following that, we just do a small sanity check of the GPU, which we found that we have perfectly fine. Then we load the base model and the tokenizer right over here. And then, so basically, we configure the LoRA adapter here. We define a LoRA config. We give the rank, the alpha dropout, and the base model with the specific parameter. So this is the main step where we configure our model and we pass the alpha and the dropout. As you can see that rank of the LORA adaptation, low rank adaptation. So this is the main part where we state how are we gonna fine tune this model. So the setup is right over here. It says that the base model is loaded, and as you can see that model parameter count with LORA adapters 0.4680 million. So which means that we are using LORA adapter right over here. Now for the step 4, right over here we load our data set alpaca style. We map and format the examples and select a subset. So yeah, we have loaded the data set right over here just to do a quick sanity check as we did in the previous video. And now this is the tokenization and the formatting. What we do is apply the truncation. So after this step, the output is a tokenized data set ready for the training. As you can see, embeddings are converted into the numerical values. All right. Then we move to the LORA setup. What exactly happens over here is we define the training arguments customized for the LORA. Now, what is happening differently as compared to from the full fine tuning over here? We pick a higher learning rate, as you can see, because fewer parameters are being trained, so higher learning rate makes more sense. We use a modest batch size and a gradient accumulation for memory efficiency, and we still enable the FP16 mixed precision to speed up things. So this is a set of hyperparameter that we are using. That this is important. That why are we using the higher LR since a small number of parameters are updated over here. Yeah, the following step still remains the same. Uh, Fine tuning of the LORA. and we run the actual training using the trainer API. We will be prompted to use the API from the weights and bias. So please update that. As you can see, I'm using my API, and then you see with each step how the training loss is being decreased from 16.2528. Then it goes at step 50, it goes to 15.15. So yeah, finally we save our model, and here is an inference of how it performs. uh, we give a set of instruction, explain how binary search algorithm works, and it has precisely given this was the instruction and this was the response. It so it took this as instruction and it gave this. The binary search algorithm is used to find the target value by searching from a value in the middle of the array, precisely giving how the algorithm exactly works. And the second is like write a snippet that's reverses a linked list, so it has also given a code for that. So uh, this is very fascinating that how this uh, parameter efficient fine tuning technique works really well, and it precisely gives the response for it. So this is it for this video. Thank you.